Hello friends, today we're going to be looking at solving one-step equations. I have my guided notes here with the steps at the top in case you need to refer back to them. They are always up there for you. Let's go ahead and dive on in. So example 1, we have x minus 3 equals a negative 5. So I have my variable is x. My constant is 3. And the rest of my balanced equation is negative 5. So I have already written the equation. I'm recognizing the variable is over here on the left. And in order to isolate that variable, I'm going to use inverse operations. The inverse of subtracting is adding. So I'm going to add that constant of 3. Now this is a balanced equation, and in order to keep it balanced, kind of like a scale in science, if you add something to one side, in order to keep it balanced, you need to add an equal value to the other. So I'm going to add that constant of 3 to the right-hand side as well. Negative 3 plus 3 is 0. On the left, I'm left with x. Negative 5 plus 3 is negative 2. So I believe my solution is negative 2. In order to check that, I'm going to rewrite my equation. And then wherever I see x, I'm going to add a negative 2 instead. So here I see an x. I'm going to have a negative 2 minus 3 could possibly equal negative 5. Negative 2 minus 3 is negative 5, which does, in fact, equal negative 5. That checks out, so my solution is negative 2. Let's come on down to example number 2. Now we have a negative n over 5 equals 3, and something you may have forgotten or just may still have some brain for is this fraction bar right here also says division. So what this says is n divided by a negative 5, some number n divided by a negative 5 is equal to 3. Since I'm seeing division, I'm going to use the inverse operations of multiplying. And since this negative can't really be attached to that variable, we're going to attach it here to the constant. So multiply both sides by a negative 5 using inverse operations. Negative 5 times negative 5. Oh, sorry. Negative 5 times a negative 1/5, because that's what that fraction there is, zeroes out. We have n equals 3 times the negative 5, so negative 15. I feel like that the solution for the value of n is negative 15. Of course, I'm going to come check. So n over negative 5 equals 3. Negative 15 over negative 5 could possibly equal 3. Negative divided by negative is positive. 15 divided by 5 is 3. So that does check out because I have the same value on both sides. My solution n is equal to negative 15. Let's go ahead and slide on down to examples 3 and 4. This time we have a decimal. 9/10 is equal to some number y plus 2 8/10. This time the variable's on the right-hand side. It doesn't really matter what side the variable is on. A lot of times we prefer it to be on the left, but it's fine to be on the right. We are still going to isolate it using inverse operations. So I have addition. I'm going to subtract that 2 8/10. Remember, when you're adding and subtracting decimals, you want to make sure that those decimals do line up. This zeroes out, and we have y on this side. 9/10 minus 2 8/10 would be, well, if I had 1 and subtracted, it'd be negative 1 8/10. So this would be negative 1 9/10. So I think my solution is negative 1 9/10. Let's just go ahead and check. 9/10 equals y plus 2 8/10. 9/10 equals a negative 1 9/10 plus 2 and 8 tenths. I could also rewrite this as 2 and 8 tenths minus 1 and 9 tenths. So I would end up with 9 tenths is equal to 9 tenths. That does check out. So my solution is y is equal to negative 1 and 9 tenths. All right, last one here. We have 1 and 3 tenths, z is equal to 5 and 2 tenths. Because that z is flat up against that coefficient, I know that that means I'm multiplying. So I'm going to use the inverse operation of division. That zeroes out to be z. 5 and 2 tenths divided by 1 and 3 tenths. That decimal is going to slide in both ways. So I have 52 divided by 13. Maybe not my best number to multiply for 13. So I could easily use some thinking strategies over here. 13, double that would be 26. If I added another 13, that would be 39. Obviously, this is where it gets a little bit harder. Add another 13, that becomes a 2, regroups, that's 4, and 1 more is 5. So there we go, 1, 2, 3, 4. Z equals a positive 4 is my thought solution. And let's check it. 1 and 3 tenths times z is equal to 5 and 2 tenths. 1 and 3 tenths times 4 could possibly be equal to 5 and 2 tenths. And I, for whatever reason, like to see this vertically. So I have 1 and 3 tenths times 4. 3 times 4 is 12, regroup. 4 times 1 is 4, and 1 more is 5. I have one place value, so I need one place value, and I end up with 5 and 2 tenths is in fact equal to 5 and 2 tenths. My solution is z is equal to 4. That is correct. At this point, I want you to pause the video and do the you try 1 and 2. Feel free, if you get stuck, to rewind the video and watch again, or use the steps at the top. Go ahead and pause the video, and I'll see you in just a minute. And you're back. How did you do? Okay, great. Good to know. Good to know. All right, so let's just check your work just to make sure you are as awesome as you feel. Here we have inverse operations to subtract 3 from both sides, zeroing out, n is equal to negative 7 minus 3 would be negative 10. My check, of course, would be n plus 3 equals negative 7. Negative 10 plus 3 could possibly equal negative 7. Negative 7 does in fact equal negative 7, so my solution of negative 10 is correct. How'd you do? Yeah? Cool. All right, so then we have z divided by 25 is equal to negative 4 and 5 tenths. Of course, I see division, so I'm going to multiply by 25 on both sides. Whatever I do to one side, I do to the other. Z is equal to 25 times negative 4 and 5 tenths. Again, this is not something I do in my head, so I'm going to just slide over in this justification just a teeny bit. 25 times negative 4 and 5 tenths. 25, 10 and 2 is 12. Love my math. 24 times 2 is 8, and 2 more is 10. Add it down. Of course, I have this one decimal place here, so I have that one decimal place there. And a positive times a negative is a negative. So I believe that z is a negative 112 and 5 tenths, using inverse operations to find our solution. So let's check that out. Z divided by 20, that's sloppy, sorry. 25 equals a negative 4 and 5 tenths. Negative 112 and 5 tenths divided by 25 could possibly be a negative 4 and 5 tenths. Again, this is something I need to check. So negative 112 and 5/10 divided by 25. I don't have a decimal here, so I'm just going to float that bad boy up. I have negative divided by a positive, so that negative stays put. I know that 4 25s is 100. I have 12 left over, and I drop my 5. 5 25s is 125. So I do, in fact, have a negative 4 and 5/10 equaling that negative 4 and 5/10. So this is correct. If you got a negative 112 and 5/10 for Z, you are correct. If you will go ahead and look down at the other options, questions 1 to 4, choose 2, try it out on your own, and we will talk about it in class. Have a great day.